Assalamu alaikum. This is Chemistry 11th, and our today's lecture is about Mendeleev's periodic table. Now, before going through this Mendeleev's periodic table, I would like to tell you about the this Dobrinier's periodic table, and when this Newland system of classification. Since both Dobrinier's triads and this Newland's law of octaves, and they had demerits. So on those bases, as we have already discussed these two, that is Dobrinier's and Newland's law of octaves, as they had a certain demerits. So on these bases, these two systems of classification where they were discarded. Then it was Mendeleev, a Russian chemist in 1869. He studied the chemical properties of the elements and found that there was a close relationship between the chemical properties of the elements and their atomic masses. So he based his system of classification on atomic mass, and he gave his periodic law, which can be stated as that the properties of the elements or the periodic functions or their atomic masses. That is, if the elements are placed in increasing order of their atomic masses, the elements with similar properties, they are repeated after regular intervals. So what Mendeleev did, he placed the elements in order of their increasing atomic masses. Now he's considered this Mendeleev. He's considered the father of the periodic table. Now, as far as his periodic table is concerned, the main characteristics or the main features of his periodic table are number one, and the vertical columns of his periodic table, he called them as groups, whereas the horizontal rows of his periodic table, he called them as periods. Now in Mendeleev's periodic table, we can see that there are nine groups which are indicated by numerals. This is first, second, third, fourth, fifth, sixth, seventh, and eighth, and we have got a zero group. Now the elements belonging to the first seven groups have been the elements belonging to first seven groups, that is 1 2 3 4 5 6 and 7, they have been divided into subgroups which are designated as A and B. Now each of these seven groups, they are divided into subgroups A and B. Now, on the basis of their similarities in their properties, the elements that are present on the left hand side in each group, they constitute the subgroup A. So these are the subgroup A. The elements which are towards the left hand side of each group, that constitutes this subgroup A, while those on the right hand side form the subgroup B. You can see this is on the right side. Now the eighth group, as far as the eighth group is concerned, it consists of only nine elements which are arranged in three triads. You can have here, this is iron, this is cobalt and nickel. Then you have got ruthenium, rhodium, and palladium, and we have got osmium, iridium, and platinum. Now these are the nine elements which are arranged in three triads. Now the zero group, it consists in zero group, it consists of the elements of these inert gases or noble gases, since these were discovered, these elements, they were discovered towards the end of this 19th century. So this zero group, it is added to the periodic, it was added to this periodic table at the later stage. Now, as far as the periods are concerned, we can see here there are seven periods. This is 1 2 3 4 5 6 7, and I have told you that these periods, they are the horizontal rows of the and this periodic table. Now these periods, they have been as I have told you, they are numbered from 1 to 7, and they are the horizontal rows. Now in order to accommodate more elements, the periods 4, 5, and 6, you can see 4, 5, 6, and 7. This is period 4, 5, 6, and 7. So this is in order to accommodate more elements. These periods, have been divided into two halves. You can see this period number 4, it has got two halves, the upper half and the lower half. Similarly, this has also got two halves, the upper half um, and the lower half. Similarly, this period, it has also got two halves, the upper half and the lower half. These periods have been halved into two big, just to accommodate more elements. Now the first half of the elements are placed in the upper left corner. First half, they are placed in the upper left corner. You can see here the first half, the elements, they are placed in the upper left corner in each of this box. Now then we can see this the periods. The first period, you can see here, it consists of two elements only. We have this hydrogen and helium, since these noble gases were not discovered then. So it is called the as it consists of only two elements, it is called the shortest period. Now the second and the third period, this is second and third period. They have got eight elements each, and these are known as the short periods. Now, periods fourth and fifth. As far as the fourth and fifth periods are concerned, we have got 18 elements, and these are designated as long periods. These two periods consisting of 18 elements, they are called as the long periods. Then we have got a sixth period which has got 32 elements, and it is known as the longest period of the period of Mendeleevs periodic table. Now the last period, that is the seventh period, it is the incomplete period, because at that time only about 60 elements were known at that time. You can see here, although I have shown here the atomic numbers of the elements, actually I have shown here the atomic numbers of the elements. In fact, this periodic table, it was designed while designing this periodic table, as I have told you, the elements are placed in increasing order of their atomic masses. Now, since I have told you that only 16 these 60 elements were known at that time, so Mendeleev left gaps in his periodic table, and even predicted the presence of elements in such gaps, and also predicted their properties as well, which were later on found to be correct. Moreover, zero group elements, they were not discovered at that time. So he also left this place for these zero group elements. Now, as far as the lanthanides and actinides are concerned, they don't have got the proper place at their positions, and at their proper positions or at their proper places. So they have been separately put at the bottom of the periodic table. You have got these lanthanides, which consists of these elements, 14 elements. Similarly, you have got actinides, which consists of these 14. You have thorium, protoactinium, uranium, neptunium, plutonium, americium, curium, berkelium. This is californium. This is einsteinium, fermium, mendelevium, and nobelium, and this is lawrencium. So since they have got no place at their at their proper position, so they have been placed, these lanthanides and actinides, they have been separately placed at the bottom of this periodic table. Although this Mendeleevs periodic, it has got merits as well as demerits. We will discuss its merits as well as demerits in our next lecture. So this is for today. Thank you very much.